Okay, friends, please submit your attendance. I see that there are the 30 participants and only 24 submitted the attendance. 6 are remaining. The remaining member or who joined late, please send or submit your attendance in chat box. Please submit your attendance in chat box. Okay, friends, I saved the chat box. I saved it. Okay, I am going to share the screen of today's lecture. Friends, screen is shared. Well, is it visible? Mahima, screen is visible.
Yes, sir.
Okay, thank you, Mahima. Okay, friends, the name of today's topic is the cardinal point, and we know that the cardinal point, there are the three pair of the cardinal point, and which are that will be discussed here. The cardinal point, there are the 6 very important points or the 3 pair. 6 पॉइंट किंवा 3 पॉइंटच्या जोड्या येतात त्या, म्हणजे 2 पॉइंटच्या 3 जोड्या, म्हणजे 6 पॉइंट्स आहेत, त्याला आपण कार्डिनल पॉइंट्स असं म्हणतो. हियर देर आर द 6 व्हेरी इम्पॉर्टंट पॉइंट्स विथ रिस्पेक्ट टू कोएक्सल लेन्स सिस्टम. कोएक्सल लेन्स सिस्टम means the convex lens system whose principal points are to be connected by the principal axis that will be known as an thick lens called the cardinal point. That is, there are 6 points in coaxial system, or the 3 pair of a 2 point means 6 point are there. What are that? That will be known as a cardinal point. And what are the names of that cardinal point? There are the 2 principal point, 2 are the principal point, 2 are the focal point, 2 are the principal point, 2 are the focal point, and 2 are the nodal point. That is, focal points, nodal points, and principal points. These are the 3 pair, that is couple of points, couple of principal point, couple of focal point, and couple of nodal points are known as an cardinal points. The plane passing, hello, please mute yourself, please mute yourself. Okay, the plane passing through the cardinal point and perpendicular to the principal axis. Principal axis is the central line. The plane passing through the cardinal points मधून जाणाऱ्या आणि प्रिन्सिपल ऍक्सिसला परपेंडिक्युलर असणाऱ्या प्लेन्सला कार्डिनल प्लेन असं म्हटलं जातं. and there are the 3 cardinal planes. There are the 3 cardinal plane, that is the plane passing through the cardinal points and perpendicular to the principal axis of the lens is, that will be known as an cardinal plane. The information of for the formation of a image can be studied by considering image, that is the part which is on that side of the lens. If we are on this line, this side, then the image is on that side. Okay, object and images are the opposite side of the opposite side of the lenses. Then the formation of the image can be studied by considering the refraction of the rays starting from the object at various refracting surfaces of the lens. Means that, consider, just I am taking here, I am taking the annotate, and in that annotate I am drawing here the lens. This is the lens, this is the principal axis, and this, consider this is the object, this is the object. Then due to the object on that side, it will be goes, that is shear, again the on this side, and this will be the image. Okay, this is the object and this is the image. Then we know that this is the refraction, that is the ray travel through the medium, through the glass medium. If the ray is travel, that will be known as the refraction. Okay, again see here, that is the generally the microscope, telescope and other optical instrument employ combination of lenses to avoid and minimize the aberration. We know that each and every lens has an aberration, and there are the different method. There are the different scientific method to minimize the aberration. In first year, we see the spherical aberration. We see the different methods to minimize the spherical aberration. There are the different types of the aberration, and there are the different methods to minimize the aberration. If the aberration is minimized, then the image which is produced is an intense, it is focused well, and it is well illuminated. Means that here we have to minimize the aberrations. There are the different types of the aberration, that is lateral aberration, spherical aberration, and so other aberrations. But there are some methods to minimize the aberration, and using that method, if we can able to minimize the aberration, then the all type of a microscope, telescope and optical instrument has a well intense, well optical image is there, and that will be we are able to see. Okay, therefore the study of the formation of the image by considering the refraction at several surfaces of the lenses here. Therefore, to study the formation of the image by considering the refraction at the several surfaces of the lenses, the system become tedious job. We know that the refraction at edge is major. Sorry, just I am going to again share the just see the first share the okay, just I used to annotate here, and consider this is the convex lens, okay, this is the principal axis. From this edge, if we go toward this edge, the curvature is increasing, and mean then the here the curvature is increasing, and as the curvature increasing, the spherical aberration is going on increasing. Means that at a different point or the different surfaces of the lens, the aberration is different. Means that where the light is incident at that point, what is the spherical aberration, and we have to calculate the amount of spherical aberration at the each location of the lens It is very tedious job. It is very typical job, or that method is very becomes very complications. Just we can use. This is very tedious job. Therefore, the Gauss in 1841 suggests the coaxial lens system can be considered as a single unit, and using the knowledge of the cardinal point of the lens system means that the Gauss in 1841 he tried to give the generalized phenomena, generalized rule for the coaxial lens, that is like the convex lens is the coaxial lens. And in coaxial lens, how the cardinal points are to be produced in the lens system or the composite lens system, and he will be give the one of the phenomena, one of the rule, and the formation of the image can be studied with the very simple and convenient way without considering the refraction at the individual refracting surface. We know that that is the study of individual, the study of individual refraction at a different point on a surface of the coaxial system. It's very tedious, it's very complicated. This is very typical. It means this is very tough, and hence the Gauss in 1841 gives the simplified proforma to define the different images, and that proforma will be depend upon the cardinal points. And we know that there are the three pair of cardinal point, or the total six cardinal point. And then according to that cardinal point, he gave the simple and convenient method to study the refraction of the light through that coaxial surface of the lens. And according to that, we can able to get the different magnification or the optical power of that instrument. Okay, all the distances, like the object distance, we know that the object distance on the object side, the image distance on the image side, and focal length, that is the length of the focal point from the lens, that will be known as a focal length, etc., are to be measured from the hypothetical plane called the principal plane. That is, the principal plane is the one of the hypothetical plane at the center of the lens, which will be go through the principal axis, which will be perpendicular to the principal axis is the principal plane. It means that, consider if I use the annotate, and in that annotate consider this is the convex lens, this is the principal axis, and then this is the principal plane, this is the central is the principal plane, and all the distances are to be measured on image side, object side, again image side, again for the focal point, that will be all the distances are measured with respect to the principal plane, which is perpendicular, and which is hypothetical, which is at the center of the lens and perpendicular to the principal axis. That plane is known as a principal plane, and all the distances are measured from the principal plane, and such distances are used to draw the some graphs, and again that distances are known as an the distances are used for the calculation. That is, the all the distances like the object distance, image distance, and focal lengths are measured from the hypothetical plane called as an principal plane. And then the concept of the cardinal point are very convenient tool in the study of the complicated optical system. And due to that distance in the that object distance, image distance, and distance of the focal plane, that will be measured hypothetically from the principal plane, and these distances become very important. These distances become very important, and they will be give the concept of the cardinal point, and it gives the very convenient tool in the study of even complicated optical system. In optical system, this is become one convenient tool to calculate the image distances and again the object distances and focal distances inside the cardinal system or the optical system. Okay, friend. Then the next point is the definition. That is the cardinal points definition. What are the cardinal points? That is the definition. A principal point and principal plane, principal point and principal plane. Consider the following diagram. Just I am going to explain that diagram. An incident ray OA parallel to the principal axis ला parallel आहे, emerges from the lens system as the BF2 या lens system पासून तो निघतोय, where F2 is the second focal point आहे on in image space, and when the rays 1 and 3 are extended to meet each other at the H2, then the refraction of the rays at various surfaces in the lens system is equivalent to the single refraction at H2, and similarly the refraction F1C through the lens as a DE may be considered as the refraction at the N1, and the plane HP1 and H1P1, sorry, the plane H1P1, friends, plane H1P1, H2P2 drawn perpendicular to principal axis are known as a principal plane. Principal plane म्हणजे काय बघा, हा OA रे आहे रे, OA रे हा पॅरलल टू प्रिन्सिपल ऍक्सिस आहे, इथून तो मूव्ह झाला आणि पुढे जातोय पॅरलल टू, पण आपल्याला माहित आहे इथं आहे ती फोकल पॉइंट 1 आहे, इथं ऑब्जेक्ट आहे, त्याची इमेज इथं H1 दिसते, हा इकडं एक ऑब्जेक्ट आहे पण तो इमेज स्पेसला आहे, हा ऑब्जेक्ट आहे, याचं रिफ्रॅक्शन घेतलं तर याची एक इमेज दिसते आपल्याला इथं G1 G2 म्हणजे H1P1 H2P2 आणि H1P1 आणि H2P2 हे जे दोन आहेत P1 आणि P2 हे प्रिन्सिपल पॉइंट आहेत, आणि पण परपेंडिक्युलर टू प्रिन्सिपल ऍक्सिस जर मी H1 आणि P1 आणि H2 आणि P2 अशी जर मी मित्रांनो लाईन ड्रॉ केली, मी that line will be known as an principal planes. या दोन काय आहेत, प्रिन्सिपल प्लेन्स आहेत. या इमेज साइडला आपल्याला इमेज आहे F1 आहे, ऑब्जेक्ट साइडला F2 आहे, हा मी OA रे घेतला, हा तसाच पुढे जातोय मित्रांनो, तसाच पुढे कुठे चाललाय बघा, हा तसाच पुढे चाललेला आहे, या A मधून ही A लेन्स आहे म्हणजे लेन्स L1 आहे, इथं लेन्स L2 आहे, L1 मधून पुढे गेला, L2 मधून पुढे गेला, इथं ऑन इमेज साइड आपल्याला दिसतंय डिस्टन्स F2, ही फोकल लेंथ F1 आहे, फोकल लेंथ F2 आहे, आणि इथून जर मागे एक्सटेंड केले हे रेज मागे एक्सटेंड केले तर H2P2, आणि हे पुढे एक्सटेंड केले तर आपल्याला काय दिसतोय, H1P1 दिसतोय, and here that will be the principal plane. Thus principal plane H1P1 H2P2 are the locus of the point where single refraction due to the lens system is to be supposed. इथं सिंगल रिफ्रॅक्शन आहे मित्रांनो, सिंगल रिफ्रॅक्शन म्हणजे ऍट A पॉइंटला आणि ऍट D पॉइंटला, त्याचबरोबर इथं C पॉइंटला आणि त्याचबरोबर इथं B पॉइंटला, अशा पद्धतीचं रिफ्रॅक्शन आहे. हे मागं मी एक्सटेंड केलं मित्रांनो, तर मला H1P1 मिळालं, हे पुढे एक्सटेंड केलं आणि हे असं पुढे एक्सटेंड केलं तर मला H1 आणि P1 मिळालं, म्हणजे मला काय मिळालं सांगा, मला प्रिन्सिपल पॉइंट मिळाले, आणि प्रिन्सिपल पॉइंट म्हणजे काय आहे सांगा मित्रांनो, लोकस आहे म्हणून सांगितलं, आणि दॅट विल बी द वन ऑफ द लोकस ऑफ द इमेज आहे, आणि लोकस ऑफ द इमेज म्हणजे H1P1. See, the principal plane H1P1 and H2P2 are the locus of the point where the single refraction due to the lens system is supposed to be occur. If it is supposed to be occur, that will be known as an principal point. आपल्याला एक पेयर मिळाली बघा. म्हणजे आपल्याला काय मिळालं? प्रिन्सिपल पॉइंट्स मिळाले, म्हणजे प्रिन्सिपल प्लेन मिळालं. H1 P1 H2 P2 इथं हे प्रिन्सिपल प्लेन मिळालं. ओके, आता प्रिन्सिपल पॉइंट्स आहेत दॅट इज P1 आणि P2 म्हणजे एक पेयर मिळाली आपल्याला. आणि ती पेयर म्हणजे कुठली सांगा? दॅट इज द P1 and P2. P1 and P2 is the one pair. ओके, आता पुढे जाऊया आपण. Here it should be noted that incident rays 1 and 2 directed toward the H1 appears to came from H2. Ray 1 and ray 2 are directed toward the H1 and it appears to be came from H2 after emergence of the ray 3 and 4. So H1 and H1 and H2 are formed. Then H1 and H2 are the conjugate points. Conjugate points म्हणजे H1 P1 and H2 P2. In other words, the object H1 is the first principal point and H2 is the second principal point. Second principal point here they called as the units means that H1 and P1 are the conjugate points आहेत. रे 1 and 2 इमर्जिंग H1 घेतोय, रे 3 and 4 आपल्याला H2 देतोय. म्हणजे H1 आणि H2 आर द इमर्जिंग पॉइंट आहेत. दे आर कॉन्जुगेट ऑफ इच अदर आहेत. इकडं एक या पहिल्या इमेजचा मला H1 ही पहिल्या ऑब्जेक्टचा मला H1 ही इमेज मिळते, तर इकडच्या बाजूचा जो काही इमेज आहे त्याचा इकडं इमेज किंवा इकडच्या ऑब्जेक्टची इमेज आपल्याला H2 मिळते. म्हणजे हे दोघं काय आहेत मित्रांनो? दॅट इज कॉम्प्लेक्स कॉन्जुगेट आहेत. That is, in other word, the object H1 is the first principal point plane image and H2 is the second principal plane image. The unit lateral magnification M is equal to 1 असेल. That is the lateral magnification factor M is equal to 1 असेल. Hence, the principal planes are also called as the unit planes. Principal plane ला काय म्हटलं जातं इथं? युनिट प्लेन सुद्धा म्हटलं जातं. कुठेतरी ऑब्जेक्टिव्ह मध्ये विचारलं जाईल. when the lateral magnification M is equal to 1, the principal, that is the plane which are going from the complex conjugate of the principal plane are called as the unit plane, are called as an unit plane. That is, the unit plane is very, very important. Then the focal point and focal planes. The first focal point is F1 या बाजूला आहे, and the principal axis, on the principal axis of the point of the object such as the incident ray F1, and second point is the F2 on a principal point on the image side, and that converges the F2. And here the plane passing through the F1 and F2 are perpendicular to the principal axis, are perpendicular to principal axis F1 आणि F1 that is E म्हटलंय, इथं काय म्हटलंय बघू आपण. that is V's, that will be the F1 F1O आणि F2E या दोन आहेत त्या काय आहे सांगा. that is the principal images आहेत, principal images आहेत. that is F1O and F2E are called as an focal plane, and the distance of the focal plane from the focal point is the called as the focal length. F1 is the object space or the object length, object space F1 P1 F1, and similarly the distance between the focal point and the second principal point is called as the focal length, and that will be the image space, that is F2 P2 is the F2. See the diagram again. See the diagram. Friends, this is the focal point, and the focal point on the image space, that is the here the length. इथून घेतली जाते. इथं सरळ रेष मारायची म्हणजे ती काय म्हणतो आपण, ज्याला ऑप्टिकल ऍक्सिस, ज्याला आपण प्रिन्सिपल ऍक्सिस असं म्हणतो. आणि इथं आहे बघा ती लेन्थ. इथं आपण स्ट्रेट लेन्स घेतोय, इथं स्ट्रेट लाईन घेतोय, हा प्रिन्सिपल. आणि ह्याच्यामधलं जे डिस्टन्स आहे त्याला F1 असं म्हटलं आपण. हे डिस्टन्स F1 म्हटलं. आणि F1 आणि या इमेज स्पेस मधलं F1 डिस्टन्स आहे, इकडं ऑब्जेक्ट स्पेस मधलं F2 डिस्टन्स आहे. दॅट इज दिस इज द डिस्टन्स. आणि इथं जी इमेज मिळते ज्याची उंची आपल्याला बघितली असेल तर इकडं ऑब्जेक्ट स्पेस मध्ये F1O मिळते आणि इकडे इमेज स्पेस मध्ये आपल्याला F2E मिळते आणि इथं perpendicular to the plane, perpendicular to the optical axis we get the focal plane. इथं focal plane आहे, that is OF1 and EF2 are the focal plane, and these are the two focal plane, and these are essential. We have to get the data about the focal plane, that will be the focal plane. Okay, then last is the nodal point and nodal plane. आपण पहिल्यांदा काय बघितलं, प्रिन्सिपल पॉइंट अँड प्रिन्सिपल प्लेन बघितलं, नंतर फोकल पॉइंट अँड फोकल प्लेन बघितलं, आता नोडल पॉइंट्स अँड नोडल प्लेन बघायचं. आता नोडल पॉइंट अँड नोडल प्लेन कुठे आहे बघा, an incident ray G1 N1 directed toward the first nodal point N1. Gn1, N1 is the nodal point on the axis, and emerges parallel G2 N2 is the second nodal point is the N2. And for such a conjugate, for such conjugate pair of rays, the lane system behave like the parallel slab. Parallel slab म्हणजे काचेचा ठोकळा. आपण 12वी मध्ये आपण त्याचं रिफ्रॅक्टिव्ह इंडेक्स काढलेला आहे, जसं आपण कशाचा पाहतो, जसं आपण प्रिझमचा पाहतो अगदी तसाच ग्लास स्लॅबचा बघितलेला आहे. अँड लाईक दॅट ग्लास स्लॅब वी नो दॅट देर इज द two refraction angles are to be there, and that will be the theta1 and theta2 are the angles. They does not produce the reflection, it does not produce any reflection if theta1 and theta2 are the angle made by the incident and emergent rays with the axis, then the angular magnification m1 is equal to tan theta1 divided by tan theta2. आणि इथं tan theta1 आणि tan theta2 च्या व्हॅल्यू पुटअप केल्या, समजा दोघांची व्हॅल्यू जर समान असेल तर आपल्याला मॅग्निफिकेशन फॅक्टर 1 येतो, आणि मॅग्निफिकेशन फॅक्टर 1 असेल तर OF1 आणि OF2 ऑन ऑब्जेक्ट स्पेस आणि इमेज स्पेस मधले आपल्याला काय मिळत आहेत, त्याला आपण प्रिन्सिपल पॉइंट्स म्हणतोय. And thus the nodal points are the N1 and N2 are conjugate. The nodal points are N1 and N2 are the conjugate of conjugate pairs of a point having the unit magnification. Means that from diagram the N1 and N2 are the, from diagram N1 and N2, see here, that is the G, that is the, you know that is the H1 P1, and this is the refraction angle, and the central point is the G. Again this is the H to G2, and this is the refraction angle, that is the G2, and the angle is here is the theta1 and here is the theta2, but the angle theta1 and theta2 are the same. Hence tan of theta and tan of theta1 and tan of theta2 are the same, and hence the tan theta1 tan theta2 goes and it will becomes to 1. And if the m1 is equal to tan theta1 divided by tan theta2 is equal to 1, that is the magnification factor is to be the same, magnification factor is the same, that will be known as an cardinal points, that will be known as an cardinal points, then that points will be used and known as an the nodal points, and the plane, that will be the plane through that N1 and N2 are known as a nodal plane, that we gives the 3 points, that is the P1 P2 F1 F2, again N1 N2, these are the P1 P2 is the principal points, then F1 M2 are the focal points, and N1 N2 are the nodal point, and these are the three pair of the principal points, the nodal points, and the focal point are to be known as the cardinal point, and this is the diagram to explain the cardinal point. Okay, then graphical construction, that is the construction that will be known as an graphical construction of the construction of the image using the cardinal point. That is how the cardinal points are to be graphically represented. It will be represented in the following figure. Even without the knowledge of the actual refracting surface of the optical system, we if consider that there is we have not a knowledge about the practical knowledge of the refracting surface at that is the refraction, how the refraction will be occur at a different point on the surface of the lenses. We can construct graphically the position of image of a given object. If we know the cardinal point of the optical system, the points of the intersection of any two refracted rays starting from the point object and gives the position of the image, that will be gives the position of the image. It gives the position of image. Okay. See here, this is the AB is the object. This is the parallel to the this ray is parallel to the principal axis. This is goes to the nodal point and it will be goes to the goes to the focal point. Okay. Then again at the this complex conjugate, from here we get toward the F1, we go get toward the F1, the principal points. This will be the principal point. This will be the theta 1. That will be the theta 1. This will be the theta 2. Again, this point is the F1. This point is the F2. F1 point F2, that is F1 and F2. And we have to calculate X1 and X2. X1 and X2. Then we are able to calculate the graphical representation. This graphical representation, that is the intersection of the two refracted rays starting from the object point position of the image point. This intersection gives this is the image as object and this is the image. Its height is h1, its height is h2. This is the h1 h2 are the this will be known as the points, that is the principal point, again the principal point, again the nodal point, and these are the plane, that is principal plane, h1 h2 principal plane, and again the f1 and f2 are the focal points. Let's graphically find out the position of the a1 and b1. a1 b1 is the position of the a1 b1. a1 आहे, इकडे आपल्याला a b मिळाला, a1 b1 मिळाला of the object a b, and due to the optical system whose focal points are f1 and f2, principal points are p1 and p2, nodal points are n1 and n2, it will be very simple. A ray ah1, see here, a ray ah1, that is this is the ray. Ray H1 parallel to the principal axis, intersection with the first principal plane at the H1. H1 ला intersection घेतला, therefore the emergent ray starts from point H2. H2 ला सुरू होईल and second principal point म्हणजे PH1 is equal to PH2. PH1 is equal to CR. That is the PH1 is equal to PH2. PH2 इथून सुरुवात होईल आणि तो इकडे जाईल मित्रांनो, आणि दिस इज द दॅट इज द AH1 इकडं आपल्याला H2 आणि इकडं A1, आणि इथं P1 that is the P1 into BH at the same distance. At the same distance it will be shown in same distance. That is P1H1 and P2H2, and it says that is the second focal length F2 is equal to H2F2 ला आपल्याला second focal length मिळेल, second. That is at okay friends, लगेचच परत जॉईन व्हायचं. 1-1.5 मिनिटामध्येच आता लेक्चर हे एंड होईल. पहिल्यांदा तुमचा अटेंडन्स कशामध्ये द्या, मला चॅट बॉक्स मध्ये द्या. फास्टली गिव्ह अटेंडन्स इन चॅट बॉक्स. फ्रेंड्स, फास्टली गिव्ह अटेंडन्स इन चॅट बॉक्स. दीपाली गावडे, अटेंडन्स देताना फॉर एव्हरीवन द्यायचा, एव्हरीवन द्यायचा. जरा फास्टली सगळेजण अटेंडन्स सबमिट करा मित्रांनो. एकाच मिनिटात लेक्चर संपेल. पुन्हा लगेच जॉईन व्हायचं मित्रांनो. मी एवढं पूर्ण करणार आहे मग थांबणार आहे. प्लीज सबमिट अटेंडन्स इन चॅट बॉक्स फास्टली. परत लगेचच जॉईन व्हायचं आहे. मी तेवढ्याच 2-4 ओळी एक्सप्लेन करणार आहे आणि मग थांबणार आहे. सगळ्यांचा अटेंडन्स झाला का? प्लीज सबमिट युअर अटेंडन्स फर्स्ट फ्रेंड्स. Just I am waiting for 30 seconds to submit your attendance in chat box. Just I am waiting for 30 seconds. And after 30 seconds, I will end the meeting. Again, you join the same link. सेम लिंकला परत क्लिक करायचं आणि जॉईन व्हायचं. 5 ते 10 मिनिटं मी फक्त घेणार आहे. ओके, आय एम सेव्हिंग द चॅट बॉक्स अँड एंडिंग द मीटिंग. मी एंड केल्यानंतर परत मित्रांनो तुम्ही त्याच लिंकला जाऊन परत यायचं आहे लगेच. ओके, अजय कांबळे इज व्हेरी फास्ट. चला सगळ्यांनी लगेचच काय करा, प्लीज सबमिट युअर अटेंडन्स इन चॅट बॉक्स फास्टली. Fastly submit your attendance in chat box and I am sharing the screen again. Friends, fastly submit the attendance. I am going to share the screen. Submit the attendance in chat box. I am save the chat box. Can I save the chat box? Please submit your attendance in chat box fastly. Okay friends, please submit your attendance in chat box. I will going to save the chat box and again I am going to submit or share the screen. Okay friends, I am going to share the screen. Here is the screen. Okay, Mahima, that is the screen is well shared.
Yes, sir.
Okay. See here, friends. We are came to the first point. We are going to see how we construct the cardinal points in by the graphical method. That is the representation of the cardinal point by graphical method here. And the first point is the ray AH1 is the parallel to the principal axis and it will be intersect with the first principal plane at the H1. And when it will be intersect at the H1, therefore the emergent ray will be start from point H2, that is the second principal point, then P1 H1 is equal to P2 H2, and this ray will be passing through the second focal point, and that will be shown in just before I will show it before few seconds. Okay, that is the along H1 H2. The second incident ray, a ray that is AC1. A ray is AC1, central ray. See here, AC1, that is the central ray, it will be intersect at the N1 and the C1 पासून पुढे आपण डॉटेड लाईन घ्यायची आणि जिथं इंटरसेक्ट होते तिथं C2 and again draw the line through N2 toward the A1. इकडे बारकाईनं बघा, इथं A1 मधून येते ती C1 ला, इथं C2 मधून जाते A1 ला, इथं आपल्याला N1 मिळतो. दॅट इज द नोडल पॉइंट्स मिळत आहे आणि दॅट नोडल पॉइंट कसे घ्यायचे ते इथं सांगितलेलं आहे. A ray AC1 directed toward the first nodal point N1 intersect the first principal point at C1. First principal point at the C1. Therefore, the corresponding emerging rays start from the C1 on the second principal plane such as the P1 C1, P2 C2 and C1 N2 are the AC1 N1. Means that here the nodal point AC1 N1 again C2 N2 A1 is the second nodal point. Here N1 N2 are the nodal points. And third one is the ray is F1, that is the last ray. The F1 passing through the first focal point intersect the first principal point or the principal plane D1, and therefore the emerging ray from the D2 second is the PD1 and PD2 along the principal axis आहे आपल्याला, आणि हे इथं आपल्याला principal points देत आहेत. That is the principal axis parallel to the principal axis. Then the intersection of the point A1 of any two above mentioned, that is object A, thus the A1 B1 is the final image, AB is the object, then AB A1 B parallel to the perpendicular to the principal point. See here, this is the AD1 goes to the F1 is the focal point. F1 is the focal point. आलो 5-7 मिनिटात आलो, 5 ते 7 मिनिटात येतो. हो बोला बोला. अच्छा, नाही अडवणार का? काय नाही, मी आहे की, चला मी आहे, चला या काय अडचण नाही. ओके या ओके ओके आहे, मी लेक्चर मध्ये 5-7 मिनिटात मी बाहेर पडतोय 5-7 मिनिटात. ओके okay friends, okay, that is the AF1 and D1. AF1 D1 ही AF1 जोडलं की प्रिन्सिपल ऍक्सिसला जिथं जोडतंय तिथं F1 मिळतोय. दॅट इज द फोकल पॉइंट 1, दॅट इज द डिस्टन्स ऑफ द फोकल पॉइंट ऑफ द इमेज डिस्टन्सला मिळते आपल्याला. अगदी तसंच आपण इथं AF2 आणि AF2D मिळतोय ना, AF2D मिळतोय, हा आपल्याला मिळतोय इथं फोकल पॉइंट सेकंड, that is on the image side. आणि अशा पद्धतीने आपल्याला फोकल पॉइंट्स, त्याचबरोबर प्रिन्सिपल पॉइंट्स आणि त्याचबरोबर आपले सगळेच्या सगळे पॉइंट्स आपल्याला इथे मिळालेले आहेत. that is the focal point, principal point and nodal point. आणि at the same time we are going through the Newton's formula. One is the Newton's formula. And what is that Newton's formula? From figure it is clear that is the triangle ABF1. कुठला ट्रायंगल आहे बघूया, ABF1. that is the right angle triangle. At the same time ABF1 इथं ट्रायंगल कोणता येतोय बघा, इथं हा ट्रायंगल येतोय, हा, that is the F2PH1. कोणता ट्रायंगल येतोय, F2PH1. दोन ट्रायंगल आहेत, that is the ABF1 आणि D1P1 आणि F1. D1P1 F1 म्हणजे D1 F1 P1 हे दोन ट्रायंगल. मित्रांनो मी जरा इथं काय घेतो, एनोटेट घेतो. हा ट्रायंगल मित्रांनो, हा ट्रायंगल आणि हा ट्रायंगल, आणि सिमिलरली पुन्हा हा ट्रायंगल, राईट अँगल ट्रायंगल आणि हा ट्रायंगल. हे दोन ट्रायंगल हे सिमिलर ट्रायंगल आहेत, आणि सिमिलर ट्रायंगल आहेत म्हणजे एकरूप आहेत, आणि एकरूप असतील तर काय असतं माहितीये ना, मग त्या 3 कसोट्या आहेत बाजू 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 बा को बा आणि को बा या 3 कसोटीनं ते काय असणार आहेत एकरूप असणार आहेत आणि ते आपण इथे बघणार आहे न्यूटन्स लॉ मध्ये. दॅट इज न्यूटन्स लॉ. काय सांगतोय बघा न्यूटन्स लॉ. या दोन दोन ट्रायंगल आहेत ए बी एफ वन आणि डी वन पी वन. एफ वन याच्यामध्ये ए बी इज इक्वलन टू ए बी ही पी वन डी वन असते आणि बी एफ वन डिवायडेड बाय पी वन म्हणजे ए बी. इथं बघा ए बी कोणाबरोबर आहे पी वन डी वन बरोबर आहे आणि इथं ए एफ वन ही एफ वन एफ डी एफ वन आणि डी वन बरोबर आहे. याचा अर्थ काय आहे ह्या दोन्ही बाजू एकरूप आहेत. एकरूप असणाऱ्यांचा रेशो घेतलेला आहे आपण. एका ट्रायंगल मध्ये इथं ए बी पी डी वन दुसऱ्याची आणि पुन्हा पहिल्याची बी एफ वन डिवायडेड बाय दुसऱ्याची एफ वन पी वन. आणि इथं बघितलं आपण दॅट इज काय म्हटलंय बघा बट P1 D1 is equal to A1 B1 आणि F1 P1 is equal to F1. BF is equal to BF1 is equal to X1 आणि हे जर डिस्टन्सेस आपण घातले इथं P1 D1 is equal to P1 D1 इकडे बघा बारकाईनं P1 D1 म्हणजे AB डिस्टन्स आहे H, हे डिस्टन्स आहे ते X डिस्टन्स आहे आणि P1 F1 बरोबर F डिस्टन्स आहे आणि हे डिस्टन्सेस जर पुटअप केले तर फॉर्म्युला काय होतोय बघा H1 P2 डिवायडेड बाय A1 B1 इज इक्वल टू X1 डिवायडेड बाय F1. ओके. इथं आपल्याला सिमिलर दिसतंय. इथं आपल्याला काय दिसतंय बघा AB डिवायडेड बाय A1 B1 इज इक्वल टू X1 बाय F1. आता पलीकडच्या साईडची जोडी ट्रायंगलची घेतली. ट्रायंगल H2 P2 F2 is equivalent to ट्रायंगल A1 B1 आणि F2 म्हणजे कुठला ट्रायंगल लक्षात आलं मी मगाशी दाखवलेले मित्रांनो हे दोन ट्रायंगल म्हणजे हा ट्रायंगल हा ट्रायंगल सॉरी हा ट्रायंगल मित्रांनो मी परत एकदा ड्रॉ करतो ट्रायंगल बारकाईनं बघा हा ट्रायंगल मित्रांनो का हा एक ट्रायंगल आणि याचा अपोजिट ट्रायंगल हा ट्रायंगल म्हणजे हे आणि हा ट्रायंगल हे दोन्ही इक्विव्हॅलंट आहेत आणि हे दोन्ही इक्विव्हॅलंट असल्यामुळं इथं कुठली आपल्याला कसोटी लावता येते इक्विव्हॅलंट बाजूची ती कसोटी आपण इथं लावणार. इकडे बघा that is H2 P2 divided by A1 B1 is equal to X1 divided by F1 आणि मगाच्या सारखं H2 P2 is equal to AB आहे F2 P2 F2 is equal to F2 आहे आणि F2 B1 is equal to X2 आहे त्यामुळं AB divided by A1 B1 आपण जर बघितलं मित्रांनो इथं जर बघितलं तर AB divided by A1 B1 is equal to F2 divided by X1. From equation number 1 and 2 we get that is the X1 divided by F1 is equal to F1 divided by X2 गुणाकार करा तिरकस X1 X2 is equal to F1 F2 and this is the Newton's formula. आणि न्यूटन्स फॉर्म्युला काय सांगतोय बघा here the object and image distance are measured with respect to their focal length. That is the x1 x2 is equal to f1 f2 यांचा जो गुणाकार आहे object distance and image distance are equal to the product of the focal length of the object and focal length of the image and this is the one of the law that will be known as a Newton's law. Okay friends, here we are going to stop. I am stopping the sharing. Okay, Please submit your attendance in chat box. Please submit your attendance in chat box. जर कोणाला काही शंका असेल तर विचारा. पहिल्यांदा थोडं एक आपल्याकडे पुस्तक आहेत का बघा, नसेल तर मी नोट्स तुम्हाला गुगल क्लासरूमला पाठवतो, किंवा मला मेल जरी दिले तरी तुम्हाला मी मेलला सुद्धा टाकेन नोट्स सगळ्या. फ्रेंड्स, प्लीज सबमिट युअर अटेंडन्स इन चॅट बॉक्स. Please submit your attendance in chat box. दिले का सगळ्यांनी अटेंडन्स? अंकिता, अमृता महाडिक अटेंडन्स दिला का?
हो, दिला सर.
ओके ओके. मला वाटतं या पेजला कोणीही जेंट्स नाही आहे. कोणच नाही. अनिकेत, अनिकेत अटेंडन्स दिलास?
हो सर, दिला सर.
ओके 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 ओके. फ्रेंड्स, जरा वाचून बघा काय समजतंय. नाही समजलं तर मला नेक्स्ट लेक्चरला जरी विचारलं तरी चालेल. काळजी घ्या स्वतःची, कुटुंबाची. घरी राहा. अगदी फारच गरजेचं महत्वाचं काम असेल तरच बाहेर पडा, अन्यथा अजिबात बाहेर पडू नका. अगदी थोडा काळ आपल्यावर युद्धाचा प्रसंग आहे. थोडा काळ आपण ही वेळ मारून न्यायला पाहिजे. ओके ओके फ्रेंड्स, हॅव अ नाईस डे. प्लीज स्टे होम, स्टे सेफ. थँक यू. I am ending the meeting.